All right. Next page, g of x is equal to the integral from a to x of f of t dt. And a is, x is between a and b. The figure above shows the graph of g. All right, so this is the graph of g. Which of the following could be the graph of f? All right, so what do we know here? We know that if we derive g, we get f. Okay, so in essence, we want a graph which represents the derivative of what we see here, because we're interested in the graph of f, and we're given the graph of g. So what's going on with g? Well, g is increasing and then decreasing. Right? That's what's going on with g. Which means that f should be positive and then negative. All right? Because f is the derivative of g. So we need a graph which is positive and then negative. Positive, then negative, but then positive again. Negative and then positive, so those are out. Positive and then negative. Always positive. So our answer is C. 21. The graph of f prime, which is the derivative of f, is shown. If f of 0 is equal to 0, which of the following must be true? Okay. So first we got to check f of 1 versus f of 0. All right. Well, f of 1 is going to be equal to f of 0 plus all the change from 0 to 1 of f prime. Well, what's all the change from 0 to 1? It's whatever that area is. That area, that region's above the x-axis. So this is positive. So f of 1 is equal to f of 0, and we know that f of 0 is 0. So f of 1 is equal to 0 plus some positive number. So f of 1 is going to be positive. It's going to be greater than 0. F of 0 is 0, so is 0 greater than a positive number? No. So that's false. How about f of 2? Is f of 2 bigger than f of 1? Well, f of 2 is equal to f of 1 plus all the change from 1 to 2 of f prime of x dx. Well, what's the change? There it is. Again, that region is above the x-axis, so this change right here, once again, is a positive number. And f of 1, we already know is a positive number. So we're adding a positive number to a positive number, so that means that f of 2 is going to be larger than f of 1. So this is true. Is f of 1 bigger than f of 3? We can probably see what's happening here. In order for f of 1 to be bigger than f of 3, we got to take a look and see, well, we've got some, we're starting here. We add in this blue area, but we've got to subtract out the red area. Which has a greater magnitude, the blue area or the red area? Right, the blue. So we're adding, and we're taking some away, but we're adding more than we're taking away. All right, so f of 3 is going to be larger than f of 1. And again, the reason why is because f of 3 is equal to f of 1 plus all the blue area minus the red area. But there's more blue area, so that's why f of 3 will be bigger than f of 1. So this statement is false as well. Only 2 is true.